we're going to look at calculations in Java now. So we're aware of the various different data types, some of those numeric data types, and therefore we can do calculations with each one. Now, most of these use the standard symbols for calculations, so it should be reasonably easy for you to understand them. So let's jump in and do some examples. I did talk earlier about using meaningful variable names. Because we're just doing basic maths and the numbers involved don't have any meaning. I'm going to use things like A, B, and C for this. But if there is a meaning associated with a value, do try and use a more descriptive variable name. So let's say int A is 4, int B is 7. We can do things like int result equals A plus B. And then if we want to, we can print out the result. So this will be, I'm sure as you expect, 11. We can just run that and see that happen. Okay. Similarly, we can do subtraction. So we can do A minus B. So we should get a value of -3. There we go. We can do multiplication. So A times B. And we can do division. So multiplication uses the asterisk, so shift 8. Let's just make these whole numbers for a whole result for now, and I'll just do B divided by A. So we use the / for that. Okay, I've done that. Oh, B divided by 8, not A. Let's try again. B divided by A. There we go, result is 2. Now what we do need to be aware of is when we're working with integers, we will get an integer as a result. So if I change this to 10 divided by 4, if we were working with decimals, we would know the result to be 2.5. However, if we run this with integers, we will only get a value of 2, okay? If we want to find a remainder, okay, we can use the modulo operator. So we could say int remainder equals B modulo A. So in this instance, if we divide 10 by 4, we get 2 remainder 2. Okay, let's just make it clear which one's which. We'll make it 11, so we should get a remainder of 3, and we'll print out the remainder. We don't have to do this calculation, by the way, to get the remainder. We can just do B modulo A. There we go. We've got the remainder value there. This is quite useful in programming in certain scenarios, so it's worth being aware of that particular operation. We can do similar things if we were working with, for example, double or float. So if I change all these to doubles, obviously we won't, we won't worry about doing a remainder with the double calculation, but we will use a double result. Just actually before I do that, it's worth noting, you'll see here, it won't let me do this calculation, but you'll notice here, although I've declared these as double, I've actually used an integer literal to specify them, and Java is a bit flexible in this regard, and it will let us sometimes declare one data type using, for example, a literal or even a variable of another data type. It's generally a good idea to try and make sure we actually declare these using the double literal. So in this case, I'm going to make these 4.0 and 11.0, and it's not necessarily a bad idea to try and be explicit if we're changing between types, and we'll come to that a bit later in the year. Now, what I can't do, regardless of whether or not these were declared as integers, because the data type is double, I can't have the result of a calculation automatically be converted from a double to an integer. Okay, so although I could create a double with an integer value, what I can't do is do the other way around. It's going to complain here. It's going to say, oh, well, you want an integer, but you try to give me a double. Okay, so those conversions only work in certain directions. So this result obviously has to be a double, and we can run that now. What we need to bear in mind as well, might print it out actually. There we go, let's run that. So we'll get our decimal value. I did not mean to do printf, I don't know why I jumped to that, it's on print. There we go, 2.75. But what we've got to remember is that the calculations that take place when we work with a double are not done in Deanery in base 10, not in the same way we would do a calculation on paper. Okay, so this can lead to what we would maybe see as an inaccurate result. Okay, actually it only depends on the frame of mind that we're looking at. You know, if we represent a third, it's 0.333333 recurring. We never actually have a sort of perfect representation of that when we're using decimal. So whichever number system that's used under the hood, in this case obviously binary number system, we are going to get some issues that are going to show rounding or not rounding, I guess, when we move to display it as a decimal. So as an example, if we were to set B to, I don't know, 6.6 and A to 4.4, we would expect the result to be 1.5. Okay, 6.6 divided by 4.4 goes in exactly 1.5 times. Now, if we run that, actually, because we're working in binary, the computer's working in binary, we get a very, 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 very close approximation to 1.5. Okay, now, to all intents and purposes, it doesn't really matter. This is going to be close enough for pretty much any application where we need, even if we were building something with very low tolerance for error, I don't know, pistons in a car engine or something like that, we're probably going to be okay with we are, I mean, billions, thousands of billions of a unit out there. Okay, but we should be aware of that, and therefore it's generally not a good idea to use things like double for currency-based calculations, where actually we cannot split. In the UK, we can't split a penny any more than that. So typically, if we're doing calculations, we might use the integer type for our integers to represent a penny or a number of pennies in a calculation in this country, rather than using something like a double. The other thing that I haven't touched on yet, and it's worth being aware of, and I have to be honest, I'm very bad at doing this in Java. I think partly because it requires extra work, is that sometimes we won't want a value to change. Okay, so let's create an integer and we'll call it, this relates to the University of Chester, so we'll call it year founded. Okay, and we know that is 1839. Now, that is never going to change. So what we wouldn't want to do is later on in our code to write something like year founded equals 2000, for example. Okay, this shouldn't be allowed to happen. So we can mark a variable as being finished, final, or constant by using the keyword final in front of it. And if we do that, you'll see it introduces an error, and it will say, look, this final variable cannot be changed. Okay, so that's quite useful if we know that a value shouldn't be changed as part of what we're doing. This applies, you can use it for any type, so you can use it for strings. So if we had a string institution name equals University of Chester, we wouldn't want that changing, so again we could make that by marking it as final unchangeable. So then what we couldn't do is say institution name equals I don't know, Banshire, for example. Okay, it's not gonna allow us to change that value. Okay, so one thing that you should be aware of is it is possible to mix data types when you do calculations. Okay, the downside to that is you're not necessarily going to be sure of the result. Let me just give you an example. You could say it will only work sometimes. So say int result equals, and let's create a double A equals 4.5, double B equals, we'll mix a data type, aren't we? Int B equals 6. Okay, and then let's see if we can add A plus B. Okay, that is not going to allow us to add A plus B and have the result as a double. as an int, sorry, but it will let us have it as a double. Okay, so it will let us mix those data types, but again, we can only store it as a double. Okay, so we need to be careful if we're working with multiple different data type, numeric data types. Okay, in some instances, let's say x equals x. Okay, now this might be really interesting because we're now adding 4.5 to 6 to x. Okay, and you might think, well, how on earth can we add x to those other numeric values? And if we run it, we'll get a, if I print it even, might help. And run it again. We get 130.5, okay? And from that, we can probably infer that x has got a value of 120. So, you know, we could actually do something like, and actually what is going on here is that chars have a numeric value under the hood. So you can do things like int x equals x. And if we were to just print x, we'll get that numeric value, which I think we worked out as 120. Yep. So you might have preferred to guess this, but y will have a value. Oops. Let's we didn't have to change the variable name, but it kind of makes it easier to read. Y will have a value of 121. Okay. So just be aware that that is something that in the way that Java works, that you've got a numerical value under the hood for characters as well. There are also some shortcuts for mathematical calculations. So if we wanted to, for example, add 1 to a number, you can do things like this. So we could say, let's just go back to having simple int a equals 1. You can say, for example, int b equals, or if let's say we want to change a, we could say a equals a plus 1, okay, and that will add a's value to 1 and change a to 2. So if we were to print that out, we would see the value of 2 printed. It's quite common to increment something by 1, so Java gives us a shorthand for doing that. So instead of writing a equals a plus 1, we can actually write either a plus equals 1, and that's a shorthand for that, so it's exactly functionally the same. So if we run that, we'll still get an output of 2. But we can go one shorter, and we can use a plus plus. So if you've heard about the language C++, that's kind of a joke on, you know, 1 better than C. But again, this increments a by 1. So in the same way you can do a plus equals 1, you can do a minus equals 1 or a minus minus. So if we do a minus minus and print that out, we'll get a value of 0. Okay. This also works for multiplication. So if we were to have, for example, let's make a times a equals a times 5. Let's just get rid of that for now. Obviously, let's make a2 to start with to make it a bit more interesting. So we should get 10. We can run the shorthand a times equals 5. Obviously, we can't do times times because we wouldn't know what it would be multiplied by. But we can do that. So we've got 50 there. Oh, I've left it twice. Comment that one out. That's why. So we get 10. Okay. You can even do the same with division as well. Now, there is an order for calculations to take place. Okay. In all honesty, I would even have to look up what that order is. So I'm not suggesting you necessarily learn that, but what we will talk about is a way of making sure calculations take place in the order that we want them to. Okay. So if we do something like this, int result equals a plus b times c divided by d, it's not clear what the answer is. In fact, it's not clear what we want the answer to be. Does it add up A and B first? Does it do that multiplication? Does it do the division? So on and so forth. Okay, so if we know, well, we would always know, surely, the order we want a calculation to take place in, we can force parts of a calculation to take place before other parts by using brackets. So let's say we wanted to do A plus B, and then we wanted A and B, which is 6, to be multiplied by C, which is 8, which gives 48, and then divide that by 9. We'll get whatever 48 divided by 9 is. Okay. So that doesn't look right. Let's just double check this. 2 plus 4, 6 times 8. So that's 48 divided by 9. Oh no, 48. Let's have a quick look here. 2 plus 4. So we get 4. 4 times 8, of course. So 4 times 8, 16, 32. 32 divided by 9. That's still not right. Why is that not working? Just careful look at my code. Let's work it out above. So we've got, we'll do the A plus B because it's in the inner bracket. So that's going to be, well, let's write it out. 2 plus 4 times 8 divided by 9. Okay, so let's work this out. Result equals 2 plus 4, 6. So we can take those brackets out now. 6 times 8 divided by 9 equals 8, 16, 32. That's 48, isn't it? 48 over 9. Just check my maths here. 5.3. So why are we not getting the result that we expect? Let's run this again. Okay, sometimes the simplest error is the easiest one. If you're watching this and paying more attention than I have, you'll notice I'm actually printing A. Okay, so what we should do is print result. There we go. So it's easy to make mistakes when you're programming, and what you can find is that a bug like this can take a while to spot. Okay, there are generally a couple of approaches to dealing with this. One is to walk away for a couple of minutes and then come back and look at your code, and you'll almost certainly see it. Some of you may have seen it while I was doing it, spotted it way back. Okay, the other is to ask somebody to have a look at your code and see what obvious mistake you're doing. And actually there's a third where what you do is you can explain either to somebody or to some kind of imaginary. I had a student once who had a plastic duck, and he used to talk to the duck and explain what he was doing. And in the process of explaining what was going on, you'd eventually find the error. So there are some techniques for finding bugs in your code like what I had. So let's run this again. Okay, and we've now got our value of 5. If we were to compare that to what we'd get without the brackets, would we get the same or not? We would get the same. Okay, so that's quite interesting. So the order that we wanted. Let's take a different approach, and let's say we actually wanted to do C divided by D first, and then we wanted to multiply that by the result of A plus B. Okay. And you can see that gives a value of 0 because C over D, 8 divided by 9 is 0. Anything times 0 is 0. Okay. So I would suggest that we make sure that you use brackets rather than relying on the precedence of the operators to do the job for you.